I do want to talk about application performance tuning in Kubernetes. So this is a little bit more specific. And again, my name is Adam Hurt. I'm the Senior Product Manager at SolarWinds, focused on the AppOptics product. And we're going to take a look at performance tuning that's specific to Kubernetes. So one of the unique things about Kubernetes is if you make the transition to Kubernetes, you have to first Dockerize all of your applications, and then you have to set the resource constraints on those applications. So what we're going to look at here is a combination of application performance. So how well is our service responding? And we're using service response time as a measurement for that. What's the load on the application? So we're using request volume as measurement of load. And then we're going to look at the infrastructure behind that application that's running in Kubernetes. Right now, we're looking at really everything. Everything's just kind of averaged across itself. But we're going to split the stats out. And then we're going to look at our stats by service. So an example here is now we have our service response time broken out by service. And we can see that, hey, we've got some pretty big spikes in our web tier, right? We're going up to about 8 seconds. Not amazing performance. And this is running in Kubernetes. The next thing we can look at is, hey, what is the average pod that's running the web tier? What's the average CPU for that? So we can come over to our CPU, and we can see that. So in general, the booking service has higher CPU, but our web tier is the slowest. Maybe a bit of a mismatch. And then one of the things you can do in Kubernetes is you need to set the number of replica sets. The number of replica sets is just the number of pods. So I can say, hey, I'm running this booking service in Kubernetes, and there's going to be one instance of it. There's going to be one replica set, one pod. Or I could easily say there's going to be 20 times that. Let's make our replica sets 20. So we have 20 pods of the booking service, and everything is load balanced between them. One of, I think, the pitfalls of Kubernetes is it's easy to expand your replica sets. So if the web tier or the booking service is slow, you could say, great, let's just have more of those, right? Let's just increase that number, and then our performance will be better. But one of the things that happens over time is, you pretty much have finite resources in your cluster, or you end up paying more to have a bigger cluster. So then we can also look at, for example, let's look at our sum of memory, right? What is the, if you take all the pods in the cluster, who's using the most memory now? In this case, it's a Fluent decline that we're running absolutely everywhere, and our web tier because we're running 5 of those. So let's actually filter down to our web tier because we knew it was slow.
So while you're doing that, a quick question. So how do I integrate this into Kubernetes? What am I'm an admin rather than an app person, for example. What's my road to getting this into production? What do I need to include?
Yeah, so the getting the APM data, so getting the service response time, your request volume, and all that stuff, it is through an APM library. So your developers in their Docker file include our libraries just like they would any other third-party library. So if you're in Ruby, they would just add our gem to their Docker file and add it to their application, and that part's taken care of. It just, whether you're running in Docker or Kubernetes or whether you're running in a monolithic application, that part just works. For getting these Kubernetes-specific information, like knowing that we have 4 replica sets for our web tier, and it's using a total of 57, I think that's gigs of memory there. This is coming from a daemon set. So we have a daemon set that drops into Kubernetes and works really in the Kubernetes fashion. And what daemon sets do is it runs a small pod on each one of your nodes, and then it collects all of the information both from your nodes, so how much memory and CPU you have and what are the limits, as well as on a per node basis, so per pod basis. So we can get from each of your containers or pods running in your cluster, and even tagged with all the Kubernetes specific names, that really just happens automatically. You just drop our daemon set into your Kubernetes cluster, and all this happens out of the box. We do also have another deployment for Kubernetes that will pull the Kubernetes API. So we'll tell you stats like, hey, what were the desired number of replica sets for your web tier versus what's actually out there? Like, are there some in a failed state? Are you out of resources so you can't increase that number? We have that stats and that information as well. And really what these stats allow you to do is make the correct decisions about how to set your replica sets in your cluster. So we can look at, hey, how is our service responding? Hopefully we've designed this so we have some thresholds and what we expect our service metrics to be, such as response time, what we expect their volume to be. And then we can appropriately set our replica set so we're within those service thresholds, but we're not consuming all of the resources in our cluster. Everything's competing for the same resources. So it's important to understand, hey, how are these servers performing? What are they consuming? So we can set the proper thresholds for these things, instead of just keep growing the cluster and keep adding more resources and more money to our cluster.
Hey, Adam.
Yeah.
Do I end up with a dashboard per Kubernetes cluster?
So you can split this out. And one of the nice things about AppOptics is it's fully customizable. So if I want one of these charts to be bigger, if I want to add a brand new chart on here, add more metrics that make sense to me, you can absolutely do that. So by default, you have one dashboard that's basically filterable by cluster. So we can say, hey, show me the stats from only our cluster in US East 1 in Amazon or our on-premise cluster, but absolutely customizable to suit whatever your needs are.